So the objective for this video is to go through the introduction to while loops and to perform an example that we did in class that involves summing some numbers together. So as you can see here, I have my MATLAB up. Let's just talk about the concept of a while loop first. The idea of a while loop is that we will have while followed by some statement here. So maybe I'll do while 4 is less than 5. It can be anything as long as it's some sort of comparison that will output secretly a 1 if it's true or a 0 if it's false. And then I can come in here and display it's true. It's like end. So what is happening here is that this statement is being checked. And if you have some sort of comparative operator that's known as a Boolean in programming, that will output secretly a 1 or a 0. So for example, if I do 4 is less than 5, and I just type that in the command window, nothing else, you'll see that it pops out as a 1 because of the fact that that is true. If I do 4 is greater than 5, we know that's not true. We will get a 0. So this is secretly outputting a 1, meaning that it's true. And this says, while this is true, run this statement. And so what will happen is, if we click this or we start the code, we'll see that this is always true no matter what. And then we will see this on repeat continuously. So if I run this, you'll see that the word true is just constantly popping up. If I want to see this more dramatically, maybe I can pause this for half a second. So if I run this, we'll see that it just keeps popping up true, true, true. It just keeps going and going. To stop this, I can do Control C. I'll just Control C to stop codes. Again, if you run this, you'll see that it says busy on the bottom left because of the fact that code is constantly running. And I can't really do anything because of the fact that code just keeps running. But to stop it, I can do Control C. And now you see it's not busy anymore. We're back to our normal code. So an example of this might be something like x is equal to 1. Maybe I'll say while x is less than 5. I'll also pause this for a second, or maybe I'll pause it for a few seconds so we can think about it. So I started with x is equal to 1. And what I'm going to do in Excel is write a column for x so we can keep track of our numbers as a function of how many times the loop is running. So x is originally 1 based on this. We ask ourselves, is x less than 5? And the answer is yes, because it's 1. So we'll come in here and then say that x will become x plus 1. So we look at the current value of x, add 1 to it, that becomes 2. And we'll pause for a couple seconds. Come back up. X will be 2 in this situation. That's what it currently is. 2 is less than 5. That's true. So we'll come back in and then add another 1 to x, making it 3. So right now, at this point, x becomes 3. We'll come up here. We'll see that 3 is less than 5. That is true. We'll come back in again, and we will add 1 to x, making it 4. Come back up. 4 is less than 5. That is correct. We'll add 1 to our current value of x, which again is 4. So we will get 5. And now this is where the interesting thing happens. We come up, x is currently 5, and we want to ask ourselves, is 5 less than 5? And the answer is no. So if we were to display x in this case, we'll end up seeing that the final value of x is 5. So let's go through this, not display. I want to pause it for 1 second. Let me clear this. So if we run, we're going to see these numbers begin to pop up, and then as soon as it equals 5, that's when the code will stop. So if we run this, you'll see 2, 3, 4, 5, and that'll display the x at the end, which is this guy here. Now, if I were to make this less than or equal to 6 or equal to 5, that changes things slightly. So let's come back over to our code. Let's say we're at the situation where x is 4. Is 4 less than or equal to 5? That is correct. So we'll come in, we will add 1 to that 4 value. It will make it 5 again. Now we'll come up and check, is 5 less than or equal to 5? And in that situation, it is. That is true. So then we'll come in another time and x will progress up to 6 because we satisfied this condition because of that equal sign. And now we'll go ahead and add one more to 5 to make it 6. We'll come back up and now ask ourselves, is x less than or equal to 5? No, not anymore. So then we'll display the 6. So if we go ahead and run this, we'll see 2, 3, 4, 5. We'll see one more, and then it'll display that final value of 6 because of the inclusion of the equal sign. So let's go ahead and look at the example of summing. So if you look at the note set for note set 3, let me move this onto my screen. We want to do something like this, where we're going to sum numbers, 1 plus 2 plus 3 plus 4 plus 5, and so on. And we can do that for as much as we want. But I want to know how many numbers it will take until I exceed a value of 20. So let's write that down. We want to code a summing function that will see how many terms it takes until the sum exceeds 20. So let's go ahead and maybe we'll spend a second in Excel so that we can observe this. So if we do 1, 2, 3, 4, 5, 6, 7, 8, whatever, maybe I'll go ahead and say that this is equal to the sum of these numbers. And I'm just going to start deleting numbers so we can see what's happening here. So if I add 1 to a sum that's originally 0, it'll just be 1. I'll now add 2 to it. That'll make the sum go to 3. So this is our sum. I will now add 3 to it. That'll make the sum go to 6, 4, 5, and right as soon as I do 6, we see that our sum is 21. So to exceed a value of 20, we need to have 6 numbers added together. So this is 6 terms to get to above 20. That is what we were trying to do. So let's go ahead and think about how we would go ahead and code this. So let's say, for example, I define some variable, maybe I'll call it sum is equal to 0. Now you might be thinking, based on what I've discussed in class, that calling a variable sum is a bad idea, because if you look in MATLAB, you will see that there is a predefined function for sum that we will talk about a lot later in the class. But for our purposes, because we're trying to understand logic, I'm just going to call this the variable for now, and we will just overwrite that function. And what we want to do is continuously sum until the sum exceeds 20. So I want to make a while loop that will run if the sum is less than or equal to 20, while sum is less than or equal to 20. Because the key word here is the word exceeds. Exceeds 20, the first integer that exceeds that is 21. So we want to see when our while loop will exceed 20 and be greater than 20. So remember, this needs to be true, the statement that we write here, in order to enter it. And we want it to keep summing if it's less than or equal to 20. So I'll do sum is less than or equal to 20. And let's think about it. If I define the sum originally as 0, because we haven't started summing yet, we'll see that 0 is less than or equal to 20. That's true. Now we can come in and start adding things. So let's say I write sum is equal to, because we're going to keep redefining the sum, as the current sum value plus the term. So sum plus 1 at first, then we'll do sum plus 2, sum plus 3, etc. Maybe I will write this as sum plus n, and I need to find what n is. Maybe I make n is equal to 1. So what that means is we come in here and we see that sum is equal to sum plus n. So this first value of 1 will be added to sum. That will make this a 1. And now we want to increment that n up, because what we want to do is something like 1 plus 2 plus 3 plus 4 plus 5, etc. So if we're making this sum equal to the current sum plus the next value, we need to increment that value up by 1. Let's say I do something like this. And what I'm going to write this out maybe a little bit more clear. So we'll say that we'll start with n is equal to 1. Make this n instead of x. We'll say that sum is equal to sum plus n. So that means that sum will be 0 plus 1. Our sum value becomes 1. It was originally 0. So now we'll replace it with 1. And then I'll increase n by 1. So n becomes 2. I come back up. Our sum is 1. That is true. This statement is less than 20. Less than or equal to 20. We'll come in here, and now we'll say that sum is our current sum, which is 1, plus the new value of n, which is 2, which makes our sum now equal to 3. We'll then increment n by 1. That'll make this equal to 3. We will come back up and check if our sum is less than or equal to 20. It is 3, so we're good. Now we'll come in and say that sum, which is 3, that's 1 plus 2, we will now add the new value of n to it. Right. 1 plus 2 plus 3. So that means that our sum will become 6. Then we'll increment n by 1. Right now our sum is 6. That is still true. We'll come in here. Our new sum will be the previous sum, which is 1 plus 2 plus 3. And now we'll add the previous value of n, which is 4. I will make this sum now 10. And then we'll increment n by 1 to become 5. We'll come back up. We'll see that 10 is less than or equal to 20. And then we'll take the current value of sum, which is 10. So I'll just rewrite it as this, because this is 10. And then add the current value of n, which we've just incremented by 1 to become 5. So this becomes 15. And then we will increase n by 1. We get 6. Come back up. 15 is less than or equal to 20. Sum is equal to our current sum, which is 15. Again, which is these 5 values added together. And now we'll add the current value of n, which is 6. That makes this 21. And then n goes up by 1, and that's 7. I want you to think about what happened here. So if I were to display n, which is the number of terms, if we run this, we'll see that 7 is the answer. But we already said that the answer is actually 6, because this is the number of terms that gives us the sum exceeding 20. So what's wrong with the way that I wrote the code? We have to change the order of things, because this extra n equals n plus 1, the location of it, even though the sum becomes satisfied right here, this whole while loop will run, and now we'll end up adding an extra n. And that's not the right logic. We don't want to have an extra n. We have to be careful. And there's a few ways of fixing this. One simple way is you catch it, the display of n minus 1. Now, if you run, you'll see that it becomes 6, which I think is kind of like, I don't know, kind of a guess and check, like, oh, I didn't get the right answer, let me subtract 1 from it type of thing. But I'd rather us get the logic perfectly right. Let's say that we put this first here. We'll delete this. And let's see if we can redo this. So I'm going to go ahead and delete this. Now let's go ahead and start again. I say that n is 1. I come in here, and then I make n is equal to 2 right away. And now I say that sum is equal to sum plus n, which becomes 2, which we know is not right because we're trying to add 1 plus 2 plus 3 plus 4, etc. So this isn't right because of the fact that we have this starting at 1. So instead, let's make this start at 0. And now let's go ahead and run through this one more time, and I'll do it again slowly. You can fast forward if you need to, but if you're struggling, I want you to watch this and understand what's happening. So both of these values start at 0, And I'm going to come in and say, and check if the sum is currently less than or equal to 20. It is. I'll then increase n by 1. And then I'll say that the sum will be the current sum plus n. So that becomes 1. And I'll do here an expanded form like I did before. That's 1. We come back up, our sum is less than or equal to 20. We'll then add 1 to n, so n becomes 2. And now we're going to take our previous sum and add n to it. So our previous sum was 1, and we'll add n to it. Take this out of it. That'll make the sum 3. We come back up. We see that sum is less than or equal to 20 because it's 3. We will add 1 to n, and then we will add this new value of n, this 3, to the previous sum. That makes this 6. Come back up. 6 is less than or equal to 20. N has to increment by 1. We will then go ahead and say that our sum will become the previous sum, which is 6, plus the new n. That's 10. Come back up. 10 is less than or equal to 20. We will add 1 to n. Our sum will then become 15. That's 1 plus 2 plus 3 plus 4. Plus our new value of n is 5. Come back up. 15 is less than or equal to 20. We'll say that n is equal to n plus 1. That is 6. Then we'll say that sum is equal to the current sum plus n, which is 21. And then we come back up. 21 is not less than or equal to 20, and then we'll come out and display n. So if we run this, now we will get the right answer. So the order is extremely important when you're writing code, because depending on where you place things, you might end up doing an extra step that gives you the wrong answer. So it's extremely critical that you're paying attention and thinking to yourself, am I doing things correctly? Now, of course, in MATLAB, you can troubleshoot and just, run the section and see if you get an answer that makes sense. But what if the problem's more complicated and I want to know what the number of terms is to exceed 7,128? I run this and I get 119. Are you going to run on your calculator 1 plus 2 plus 3 all the way up to 119? That seems like a lot. So there's two things to think about. First, you can go ahead and make this problem simpler and pick a value like 20, for example, and run it and make sure if it makes sense, and it does. You can make tables on paper like we did here to fully understand what is happening as we progress through the code. And then just make sure that your answers match the logic. So when we did this on paper, we see that n is 6. Our answer better be 6. It is? Okay, our code's pretty good. So now what's nice is that if I were to make this any number I want, I can go ahead and see how many terms I need to exceed it. And that can be pretty useful depending on your application. Okay, I hope that this helps. If you have any questions, please come talk to me. Thanks.